So this is technically section 3.8. And as I mentioned before, we're calling it rebasing. It's not really what it is, but there's not really a name for it. So I am not going to test you on this topic, but it is something that your pre-calculus teacher will expect you to know. Evelyn, come grab a worksheet. Understanding the powers, there's a couple things that I want you to be comfortable with. And one of those is just why that negative exponent thing works. So if I have, let's say, x to the second over x to the sixth, if I use my exponent rules on that one, my properties of exponents, I'm going to do 2 minus 6, which is going to give me x to the negative fourth. The other way to look at that is if I have, whoops, just two x's, x times x on the top, and x times x times x times x times x times x on the bottom. Two of those divide out, and what I'm left with is 4 x's, or x to the fourth on the bottom, which means I have to write that as 1 over x to the fourth. So that is why that negative exponent rule works. So that's why this is going to be 1 over 16. That's going to be 1 over 2 to the fourth. So that's the negative exponent part. The other part you need to make sure you understand is if I have x to the a to the power of b, what do I do when I have a power to another power? What do I do with those exponents? Multiply them. So that's x to the a times b. So that's another thing you're going to need to know as we go through this process. The reason I had you write all these down is because this is going to give you, kind of serve as a basis for a way to rewrite things. Basically, you're going to be taking some numbers and changing them back to an exponent so that you can work with solving. So if we just look at A real quickly, if I have 2 to the 3x minus 1 equals 2 to the 2x plus 2, what do I know about those two expressions? They equal each other. If my base is the same, then my exponents have to equal each other. So all I have to do is 3x minus 1 equals 2x plus 2, and solve for x. So I have 1x, or just x, equals 3. And that's it. In this particular one, we're already given the same base, so that's not a problem. If we jump down to part E, if we jump down to part E, do we have the same base now? No, we do not. But how can we rewrite the number 9? 3 squared. So if I have 3 to the x plus 1 equals 3 squared, I'm writing 3 squared instead of 9, and then putting that power there to the x, then this is going to be 3 to the 2x. So that's what we're referring to when we're talking about rebasing. So now all I have to do is take my two exponents and set them equal to each other. X plus 1 equals 2x. And then solve for x from there. So we'll take a look at, so we've got 7 to the power of x minus 2 and 49 to the power of x plus 3. So what do we want to change the base on? 49 is going to become 7 squared. So I have 7 to the x minus 2 equals 49, oops, not 49, 7 squared to the power of, and I'm going to put in parentheses, x plus 3, because the point that Ilsa brought up is that we're going to have to, when we multiply our exponents here, we have to distribute. So this is going to be 2 times x plus 3. So we'll distribute and solve for x for that. Questions on that? So once we have it to the same base, then we can just deal with the exponents alone. Questions on that? Yes.